in physics, for example, one thinks about classical physics and one thinks about quantum physics. That was a division that kind of started 100 years ago with the development of quantum mechanics. And in general, quantum physics tends to be about very small kinds of things like atoms and below, so to speak. And classical physics is kind of what governs the behavior of bigger systems. So what characterizes quantum behavior is, well, partly just they're different kinds of things. So one can say, I mean, the word quantum refers to kind of the idea that things are discrete, like the spins of particles are discrete, the energy levels of things are discrete, and so on. That's what the sort of term quantum in its rawest form means. In practice, kind of the way that one thinks about sort of behavior of systems is a bit different between classical physics and quantum physics. In classical physics, for example, when one thinks about the motion of something, there's a definite law of motion. And when you throw the ball, it follows a definite trajectory that is determined by its laws of motion, which depend on gravity, drag if it's in air, things like this. In quantum mechanics, sort of the key idea as it's emerged over the last, I don't know, 50 years or so, is that things don't follow definite trajectories. They follow a whole cluster of possible trajectories. And what we measure is some probabilistic average of those trajectories. So in other words, in classical physics, definite things happen. In quantum physics, there is this sort of possibility of many things happening. And then there's this kind of tricky business of saying, well, what do we actually measure? What is it about those many things that can happen that we actually perceive? And that's a complicated story that has confused things about quantum physics for the last basically 100 years. I think in our models of physics from the last few years, we have a much better understanding of what quantum mechanics really is, and that it really is associated with many branches of possible history for the universe, both the branching of those paths of history and the merging of those paths of history. That would take us a bit far afield to talk about that kind of thing, but I think we're getting a better conceptual understanding of this difference between classical physics and quantum physics. Classical physics, definite things happen. Quantum physics, there are these many paths of possibility, and some aggregate or average or something of those paths is what we perceive.